And but at the same time, if you want to cool something and if you want to heat something, there should be more heat transfer. Okay, so if I want to keep a heat something, I have to put in a furnace, and unless there is a good heat transfer, I cannot. In the same way, if I want to produce steam, I have to have good heat transfer to the water so that there will be production of the steam. So in that way, sometimes I want increase in heat transfer, sometimes I want decrease in the heat transfer. Okay, so and the heat transfer modes are conduction, convection, and radiation. And conduction, because of the molecular vibration within the system, there will be heat transfer from the high temperature region to the low temperature region. And when you come to the convection, there will be solid and liquid interface will be there, and there will be heat transfer between the solid and the liquid. So to the one side based on which is of high temperature. And again, the convection, we have natural and forced convection. And if it is just leave it to itself and if there is a heat transfer, that is natural convection. If you put a hot egg in the air, and so it takes up the cool air here and gets hot, and the hot air goes off, and again there will be a recirculation of air taking place, and naturally the egg gets cooled. If you want to cool it faster, I have to blow air on that through fan or something, blow air, and so this is forced convection, and which needs some medium. In conduction and convection, we need some medium. But in radiation, we don't need any medium. So there can be fire here and you are sitting there and you will get the heat of that. So by radiation. So these are various modes of heat transfer. And in the radiation also, suppose if you take radiation falling on a surface, solar radiation, some of it gets absorbed and some of it gets reflected and some of it gets transmitted. There are three types happens. If you take a opaque body which is non-transparent, and there will be only absorption and reflection, and so some of it gets absorbed and the remaining things gets reflected. Okay, so Q dot reflection is 1 minus alpha into Q dot incident. You know about absorptivity, reflectivity, transmittivity. This you have studied in your BME. Okay, it is just a small problem. Consider a person standing in a breezy room at 20 degrees centigrade. Determine the total rate of heat transfer from this person if the exposed surface area and the average outer surface temperature of the person are 1.6 meters square. It is the surface area of the body, and 29 degrees centigrade is the outer surface temperature of the person, respectively. And the convection heat transfer coefficient is H, that is 6 watts per meter square degree centigrade. And so if it is like that, so you can find out what is the heat transfer, because the heat is transferred by convection and radiation, and how much heat is lost by the person. You can just find out. So Q convection is HA Ts minus Tf, where this is surface temperature and this is the room temperature. And so 6 into A is 1.6 meters square and this. And you know that radiation is equal to sigma epsilon A into Ts power 4 minus T surrounding power 4. Surface temperature is known, surrounding temperature is known, area is known, and sigma is the Stefan-Boltzmann constant, and epsilon is the emissivity. And the emissivity of the body, if you take it as 0.95, you will get the radiation loss from the body. So this total heat transfer from the body by convection is 86.4, by radiation is 81.7 watts. So normal situations, how you can find out these things, you can easily understand by seeing such type of practical problems. And here some of the things are neglected. If you see, the heat transfer would be much higher if the person were not dressed, since the exposed surface temperature would be higher. Right? Thus, an important function of the clothes is to serve as a barrier against the heat transfer. So when you are wearing the clothes, it forms a barrier about the heat, for the heat transfer. And another thing, in the preceding calculation, heat transfer through the feet to the floor by conduction, we have not considered. But because which is very small, it is neglected. But there will be all the three modes will be taking place, and some of it we can neglect compared to the, so because it is 86.4 and 81.7, if you get some 3.5 or something, so that can be neglected compared to this total heat transfer. Okay, that is the way we can just estimate what is the heat transfer from a body at some surrounding temperature. And so there is in the third chapter, which is the properties of pure substances. He talked mainly about evaporation and boiling. Many times people have a bit of confusion between what is evaporation and what is boiling. Uh, can anybody highlight what is the difference that you know? What is the difference between evaporation and boiling?
Boiling takes place at specific at atmospheric pressure 100 degrees centigrade, sir. But evaporation does not have a fixed temperature, sir.
Then why evaporation takes place? So both have phase change, right? Both evaporation and boiling has phase change from liquid to vapor. So why that takes place when the temperature is low? Okay, good. You have tried. It's nice.
The molecules underneath the first layer will absorb heat from the atmosphere, and continuous absorption makes it.
Yeah. Actually, the vapor pressure, when the vapor pressure is lower than the saturation pressure, water itself. Okay. So actually, the main difference is evaporation takes place at water vapor interface, and boiling takes place at solid water interface. When the solid that is in touch with the water is having temperature more than the saturation temperature, it gets boiled. And so another difference is there will be bubbling in the boiling, and in the evaporation there will not be any bubbling. Okay, these are the main differences. So we will discuss in detail. So we know that partial pressures we have studied, but we have studied for mixture of ideal gases and real gases, but we didn't study about air vapor mixtures. So you will have this study in refrigeration and air conditioning. When you study R&AC in your final year, where air conditioning is there air water vapor mixture we will study. Okay, here we will just have a brief thing. And because air contains atmospheric air contains air and water vapor mixture mainly. So water vapor has its own partial pressure. So atmospheric pressure is the sum of dry air pressure and the vapor pressure PV. Okay. And another thing is about phase equilibrium. Okay. So whenever there is a concentration gradient, suppose if I put a salt here, so here there is more concentration of salt, here less concentration of salt, and so there will be it tries to the physical quantity in the medium. Nature tends to equalize the things by forcing a flow from the high to the low concentration region. Okay, so this salt actually gets spreaded, and you will get more salty water and less salt here. So this is about this thing, but that is not important. Here, when open to the atmosphere, water is in phase equilibrium with the saturation pressure of the water. If the saturation pressure of this water and vapor pressure in the air are same, then it is in equilibrium. But when the vapor pressure is less, then there will be evaporation taking place. Okay, so evaporation occurs at the liquid vapor interface when the vapor pressure is less than the saturation pressure of the liquid at a given temperature. Okay, water in a lake at 20 degrees centigrade, for example, evaporates to air at 20 degrees centigrade and 60% relative humidity. So this humidity is another important thing, okay, because vapor pressure depends on the relative humidity. That is how much vapor is there. Okay, so in the air, the vapor content may vary based on the day and place and time and everything. So based on the relative humidity, the vapor pressure depends on that. So at 20 degrees centigrade and 60% relative humidity, since the saturation pressure of water is 20 degrees centigrade is 2.34 kilopascals, and the vapor pressure is equal to 1.4 kilopascals. So vapor pressure is less, and the saturation pressure at the 20 degrees centigrade is high, and so there will be automatically evaporation takes place. And other examples of evaporation are drying clothes, fruits, and vegetables, and the evaporation of sweat to cool the human body, and the rejection of waste heat in wet cooling towers. And note that evaporation involves no bubbling formation or bubble motion. And similarly, boiling occurs at the solid-liquid interface when a liquid is brought into contact with a surface maintained at a temperature sufficiently above the saturation temperature. If surface temperature is more than saturation temperature, the bubbling takes place and the boiling takes place. So example, at 1 atmosphere, for example, liquid water is in contact with a solid surface at 110 degrees centigrade. It boils since the saturation temperature of water at 1 atmosphere is 100 degrees centigrade. So the boiling process is characterized by the rapid motion of vapor bubbles that form at the solid-liquid interface, detach from the surface when they reach a certain size and attempt to rise the free surface of the liquid. So because these bubbles will go up and again the surface gets exposed to new liquid and that also gets boiled. So when cooking, we do not say water is boiling unless we see the bubbles rising to the top. Okay, only when bubbling is there, we call it as boiling. Otherwise, it is like evaporation. Okay, this is evaporation, where this evaporation takes place between water and vapor interface. And here the boiling is taking place. You can see the boiling, bubbling, and all, and between surface liquid interface. Okay, that is the main difference between evaporation and boiling. And on a summer day, the air temperature of a lake is measured to be 25 degrees centigrade. This is a problem related to evaporation. And determine the water temperature of the lake when phase equilibrium conditions are established between the water in the lake and the vapor in the air for relative humidities. Suppose the relative humidity is 10 or 80 or 100% of the air. What is relative humidity? It is the ratio of partial pressure of water vapor to the equilibrium vapor pressure of water at a given temperature. So you can find out for relative humidity 10%, the vapor pressure is equal to relative humidity into saturation temperature, saturation pressure at 25 degrees centigrade temperature. So this you can see from the saturation tables. It is 3.17 kilopascals. So I can calculate what is the vapor pressure. It is 0.317 kilopascals. If it is 80% relative humidity, the vapor pressure is this. And if it is 100% relative humidity, the vapor pressure is this. Okay. And so the saturation temperature corresponding to this, if you see the saturation temperature, again from the tables, saturation tables, it is -8 degrees centigrade, and this is 21.2 degrees centigrade, and this is 3.25 degrees centigrade. So what happens? Therefore, the water will freeze in the first case. So when the relative humidity is very less, that is 10%. So what happens? Because of the evaporation, the temperature of the surface comes to -8 degrees centigrade, which is freezing temperature. So the water will freeze in the first case, even though the surrounding air is hot. Okay, so surrounding air is at 25 degrees centigrade, but still it gets frozen. And in the last case, the water temperature will be the same as the surrounding air temperature because it is 100% relative humidity. It is completely in equilibrium. Okay, so that is the way we can see. Sometimes we don't understand the systems, but if you know the physics of it, we can understand it. So the next chapter, it talks about thermodynamic aspects of biological systems. Okay, it's a very good informative thing. So it talks about our biological system, our metabolism, and what type of foods we take, and what are the energy contents in that, and how we are spending it, and how much we have to consume each type of thing, like all nutrition things, and some of the things you can understand, because nutritionists, they talk something, and they may not talk about thermodynamics and all. Okay, so biological systems are primarily made of 4 simple elements: hydrogen, oxygen, carbon, and nitrogen. And in the human body, hydrogen accounts 63%, oxygen 25.5%, carbon 9.5%, nitrogen 1.4% of all the atoms. So the remaining 0.6% of the atoms comes from 20 other elements essential for life. And by mass, 72% of human body is water. The building blocks of living organism are cells, which resemble miniature factories. These cells of our body are like miniature factories performing functions that are vital for survival of the organism. And so a biological system can be as simple as a single cell. The human body contains about 100 trillion cells with an average diameter of 0.01 mm. The membrane of the cell is a semi-permeable wall that allows some substances to pass through while excluding others. So in a typical cell, thousands of chemical reactions occur every second, during which some molecules are broken down and the energy is released, and some new molecules are formed. So this high-level chemical activity of the cells, which maintains the human body at a temperature of 37 degrees centigrade while performing the necessary bodily tasks, this is called metabolism. So whatever activities go in the cell, it tries to maintain our body temperature at 37 degrees centigrade, and this process is called the metabolism. And basal metabolic rate, even if you are not doing anything, okay? In simple terms, metabolism refers to the burning of foods such as carbohydrates, fat, and protein. And the rate of metabolism in the resting state is called the base metabolic rate, which is the rate of metabolism required to keep a body performing the necessary functions like breathing, blood circulation, and all. Even if you are not doing anything, our body will be doing inside many things, okay? So external activity is zero, but internal activity will be always there. So what is the minimum metabolic rate is needed for this when you are at rest or not doing anything? So for an average male of 30 years old, 70 kg, 1.8 meters square body surface area, the basal metabolic rate is 84 watts. So just when you are sitting and just reading or something like that, your metabolic rate is 84 watts when resting. So you are releasing heat into the atmosphere, 84 watts, okay? So because it will be generated in the body by metabolism of the cells. And as you increase the physical activity, there will be increase in the metabolic rate. And so the metabolic rate increases with the level of activity, and it may exceed 10 times the basal metabolic rate when a body is doing strenuous exercise. So that is two people doing heavy exercise in the room may be supplying more energy to the room than a 1 kilowatt electric resistance heater. So two fast dancing couples supply more energy to your room than a 1 kilowatt electric resistance heater. They will be releasing 1.2 kilowatts. So the fraction of sensible heat varies from 40. Whatever heat we are releasing, some of it is sensible heat, some of it is latent heat. Okay, so the fraction of sensible heat that varies from about 40% in the case of respiration in the form of latent heat. So there are some different activities and different equipment that are given, which may release heat of 300 watts. Okay, so it is a 300 watt fan, and this is 300 watt refrigerator. This is a heater, 300 watt heater. This is 300 watt TV. And two people just if they are discussing something, they are each person dissipating 150 watts, and both of them together 300 watts. Or there may be 300 watt bulbs, or there may be a computer with 100 watt for computer and 200 watt for monitor. And there may be solar energy coming. So all these are equal energy that is coming out of them into the room. Okay. And food exercise. And so there are three major groups of food. We take carbohydrates, proteins, and fats. And carbohydrates are characterized by having hydrogen and oxygen atoms in a 2:1 ratio in their molecules. The molecules of carbohydrates range from very simple, plain sugar, or complex like starch, and bread and plain sugar are the major sources of carbohydrates. And proteins are very large molecules that contain carbon, hydrogen, oxygen, and nitrogen, and they are essential for building and repairing the body tissues. And proteins are made up of smaller building blocks called amino acids. And complete proteins such as meat, milk, eggs have all the amino acids needed to build body tissues. And plant source proteins such as those in fruits, vegetables, and grains lack one or more amino acids and are called incomplete proteins. Okay. And fats are relatively small molecules that consist of carbon, hydrogen, and oxygen. And vegetable oils and animal fats are major sources of fats. And most foods we eat contain all three nutrition groups of varying amounts. So the typical average American diet, okay, it is because American book, it is given American diet consists of 45% carbohydrates, 40% fat and 15% protein, although it is recommended that in a healthy diet, less than 30% of the calories should come from the fat. So whatever we are getting from the fat should be less. And how to find out what is the energy that contained in various food items. And this is bomb calorimeter is used. So here, whatever you want to analyze, you keep it here, you burn it, and which is immersed in the water, and the water gets heated up, its temperature rise, and you find out what is the heat. Gets converted into carbon dioxide. And so that increases the temperature of this, and find out what is the increase in the internal energy of the water. And that amount of energy is the calories content. Okay, here another important thing is, though we call it as calories, it is not calorie, it is kilocalorie. Whenever we talk about food and we say calories, they are kilocalories, but it's a misnomer, right? Though we say calories, they are kilocalories. And so it is just an example given. If suppose if you are taking some cookies, and if you take the box, you will be given the fat content, protein content, carbohydrate content, and other contents. And so each gram of fat, it produces 9.3 calories per gram. And each gram of protein, it produces 4.1 calories. And each gram of carbohydrate, it produces 4.1 calories. Based on that, you can find out how many calories it will release into your body. Okay, so this is actually 8 grams of fat, 2 grams of protein, and 21 grams of carbohydrate is there in that. And the total calories is 169 kilocalories. So in this way, we can calculate. So the energy contents of the foods we normally eat are much lower than the preceding values because of the large water content. And most vegetables, fruits, meat, and meats, for example, are mostly water. The average metabolized energy contents of 3 basic food groups are 4.2 megajoules per kg for carbohydrates, 8.4 for proteins, and 33.4 for fats. And 1 kg of natural fat contains almost 8 times the metabolized energy of 1 kg of natural carbohydrates. Therefore, a person who fills his stomach with fatty foods is consuming much more energy than a person who fills his stomach with carbohydrates such as bread or rice. Okay, here it is given. So when the topic is food or fitness, calorie normally, even fitness also, you are spending so many calories means it is kilocalories. Okay. So how much calories we need daily? And an average man needs 2400 to 2700 calories per day. The daily need of an average woman is 1800 to 2200 calories. And so again, it depends on the activities. If it is a sedentary woman, that is a sitting woman, how much, a sitting man, how much, and for teenage boys and girls, how much. So all these things are explained here. And another thing, there are, so about, I think we are coming to the end. So it is discussed about the dieting, how much diet. And another thing, we say weight gain and weight loss. And this is also a misnomer again. It is mass weight and mass gain and mass loss, not weight gain and weight loss. Because he gives an example. A man who goes to space loses practically all his weight, but none of his mass. Okay, but we want to lose mass, not weight actually. So when the topic is food or fitness, weight is understood to mean mass, and weight is expressed in mass units. Right? So that is another important thing. And so it is discussed in detail about, so sometimes the people consume less, but they become fat. They say, well, I'm taking very less food, but I'm becoming fat. And sometimes people reduce their diet, but they may not become lean or something. So it actually depends on the body also. So researchers on nutrition proposed one theory suggests that some people have very food efficient bodies. These people need fewer calories than other people do for the same activity. Like a fuel efficient car needing less fuel for traveling a given distance. Like that, some bodies are like that genetically. they are food efficient bodies. They take less food, but they can do more activity. And it is interesting that we want our cars to be fuel efficient, but we do not want the same high efficiency for our bodies. Okay, and there are various what we think, and with less muscle tissue to burn calories, the metabolic rate of the body declines. And so here another important thing he talks about. Yeah, and shifting from a normal 2000 calories daily diet to 800 calorie diet without exercise is observed to lower the basal metabolic rate by 10 to 20%. So your basal metabolic rate also decreases. And although the metabolic rate returns to normal once the dieting stops, extended periods of low-calorie dieting without adequate exercise may result in the loss of considerable muscle tissue. So instead of with fat, the muscle tissue also gets eaten off. So with less muscle tissue to burn calories, the metabolic rate of the body declines and stays below the normal even for a person starts eating normally. And there is another thing I wanted to show.
Sorry, sir, for disturbing. But time is 11:10. Like class.
I will stop here. Okay, there are some more things which I want to talk about household refrigerators and how can we reduce the consumption of the refrigerators. And also when another chapter deals with the automobiles. And if you want to conserve the energy while driving the automobile, what are the things you have to consider? All those things are discussed. So we will continue in the next class tomorrow. And depending on how much interesting, I don't know. So if the people continue to attend the class, I will feel it is important and useful. Okay. But as far as the exams are concerned, this may not be giving you any marks and all. But when you attend the interviews or when you write some tests and all this information is very useful. Okay, thank you very much. And we'll go to the story fast.